So derivatives of inverse functions. F and G are inverse functions such that g of x is equal to f inverse of x. And two functions are inverses of each other if f of g of x is equal to x and g of f of x is also equal to x. So f and g here are inverse functions. And we know that for inverse functions, the domain and the range, or the x and y values, are switched. So if the coordinates of the original function is AB, then the coordinates of the inverse function is BA. To find the derivative of the inverse function, and this derivative is denoted by any of these three notations, f inverse B prime, or f inverse prime of B, or G prime of B, since f inverse is equal to G. So here are the steps. 1, set f of x is equal to B, and then solve for x. So B is whatever is inside the parentheses. So take that number, take that value, and plug it into your f of x, then solve for x. The value that you will get for a is the a value. That is the x coordinate of the original function. And b is the y coordinate of the original function. And then find the derivative of the given function and evaluate that uh, at a. So find f prime of x and then evaluate at f prime of a. Now, we know that the formula for the derivative of the inverse function is given by this equation. So f inverse prime of b is equal to 1 over f prime of f inverse at b. So what happens here is, since f inverse of b is equal to a, right? Because your coordinate point is BA. So if x is equal to B, then your y is equal to A. So f inverse of B is equal to A. So replacing that here, substituting it here, we got f inverse prime of B is equal to 1 over f prime, f inverse of B is equal to A. Okay? So that in the third step, after finding f prime of A, you take the reciprocal of that, and that would be the derivative of the inverse at B. Let's take one example. Find the derivative of the inverse function f of x equals x cubed minus 4x squared plus 7x minus 1 at x equals 1. So this is the B value. Okay, that is the y value of the inverse of the original function. Okay, that's the y value of the original function. So what we do is we take this function, okay, x cubed minus 4x squared plus 7x minus 1, and set it equal to that b value. And then from here, we have to solve for x. Okay, we'll use the calculator for this one because this one is cubic. Okay, so we type into y sub 1 our function. We have x cubed minus 4x squared plus 7x minus 1. Okay, so on the left hand side we have the given function, or on y sub 1 we have the given function, and on y sub 2 we type in b, which is equal to 1, and then we graph, and then we find that intersection. So to get the intersection, we go second and then trace, and then the number 5 for intersect, and then make sure that the graphs are highlighted here. There's a blinking black icon. So click enter. It's asking for the second curve, the red curve. Click enter. and then click enter one more time. And we have these values, 0.3493708. Okay, let us take it down. 0.3493708. Okay, let me just take it out. So your x here is, let's see, where's my pen? 0.3493708. Okay, so this is your a value, which means that the coordinates at F is equal to that a value, 0.34793 0.3493708, and the b value is, the y value is 1. Okay, so this is the coordinates for your f of x. Now, second step is to find the derivative. Okay, so we find the derivative of your f of x. So f prime of x is equal to 3x squared minus 8x plus 7. Now remember, we want to evaluate this at a, okay, where your a value is this part. So we get the inverse at a, and then we get the reciprocal of that. So the derivative of the inverse at b, at 1, is equal to 1 over f prime at a. Okay, in this case f prime at that whole bunch of numbers. So we don't truncate, we do not round off at the beginning. All rounding off or all truncation should be done at the final step, okay, when you're ready to give your final answer. So in this case, we have to use the calculator. So let's take back the calculator. And remember, we are evaluating the derivative at a. So if you remember, to evaluate the derivative using the calculator, we have to do math 8. So we do math, since we're getting the reciprocal, so I'll put in 1 divided by, okay, f prime at a. So f prime is the derivative. We go math 8. Okay, we're getting the derivative with respect to x of the function. Now remember, this function, we have already put this in y1. So we have to call back y1 by going to vars, y-vars, function, click y1, okay? And then the given x value is this b value that you have here. So 0.3493708. And that is equal to point. Now you can truncate. So you can either have 0.218 or 0.219 because you just need 3 decimal places. So this is equal to 0.218 or 0.219.